Thanks. And I can slow down a little bit because that was a flash talk upstairs, so almost too quick. And for those who maybe saw that, there's a couple of people, you're going to see a few slides in this one because you might as well reuse some of the good slides. So, but let's, just take a look at kind of a general overview of invasives and fire. So thinking about, the invasives portion of all the types of habitat restoration management that we do. So to point out with the Lake States Fire Science Consortium, there is a database that's kind of pooled all the peer-reviewed and it's starting to also do kind of the gray literature. So it's a really good resource. What's interesting is also really points out the gaps. There's only 9 peer-reviewed papers that have anything to do with invasives fire, and really those papers don't tell a whole lot about the interactions of fire and invasives. So it's a big gap, and really a lot of the information resides with managers and monitoring. So a lot of what I'm going to present here is simply my land manager background with the Nature Conservancy in Michigan and Wisconsin, and basically a lot of the stuff we tried and the lessons learned with invasive species. So just again, to frame it, I mean, we only have so many tools available for any type of restoration work, and when we think about invasives, I mean, they're pretty much up there: manual, mechanical, chemical, biological, fire, water, grazing. People are starting to use more with those, or some combination. If anybody has stuff you can add to this list, great, because I'm sure I'm not the only one that would like to know if there's other tools, but they fall into this, kind of general category. Again, fire's not a silver bullet. None of these are necessarily silver bullets. It might be the combination. But we also want to make sure that we're not just applying Band-Aids. So I always got to be thinking, great, we're treating invasives, but why are they there? What is the underlying problem with them? How do we fix that rather than just continue applying a bandage? So, goal is not the flames, it's the fire effects. If you're doing fire to see the flames, I'm not sure what you're doing fire for. So it's really the fire effects. I mean, I love to see flames too, but I want to know what they're doing. So, 3 main considerations, pretty easy. Can we affect invasives with fire, so negatively impact them? How do the various invasive species affect our fire load, or fuel load, I should say, and therefore affect fire behavior? And then the third one we're not going to talk about today, but thinking about with all our fire operations that we do, how are we potentially spreading invasives? But we're going to focus on the first 2. So, again, no surprise, fire doesn't recognize the difference between a non-native species and a native plant species, all right? So if you're thinking, well, gee, we can just burn, they're non-native, we're going to get rid of them, you're probably going to have some surprises with those invasive species that love fire, so to speak. So again, here's a survey I point out where they took a look at a lot of fire and invasives work throughout the world, basically. And they found that in only 11 cases did fire actually reduce or eliminate the invasive species. But that's with a caveat, and this is something for all doing fire science or reading any of this. Most of those studies, what are they based off of? 1 wildfire, 1 or 2 prescribed burns. It may have been during the dormant season or 1 specific season. So it's a snapshot, and it really doesn't give us the big picture of what could be happening. Because I can tell you right now, if I burn in dormant season and you have a lot of spotted knapweed is going to come back probably even worse. It loves it. So we got to kind of base it or frame it like that. So some general impacts of fire and invasive species, or any plants, obviously. Size and age of the individual is important. The growth stage is extremely important. Actively growing, that's highlighted for an obvious reason because that's what we're going to hit through the rest of this. And then the growth habit, are they annuals, perennials, and perennials being grasses and forbs, or are they getting into the woody shrubs, trees, so on. So, again, these are kind of no-brainer, the effects fire can have. I mean, either it's direct, either it kills directly or shortly after. Indirect, you're stressing them into individuals, you can use another tool, chemic or so on, or you can reverse that, stress them with another one of the tools, and then follow that with fire mainly to kind of clean them out, so to speak. Active competition with native species. That's a harder one, but that one often is, for restoration, kind of the long-term goal. Can you actually get fire-dependent species in a fire-dependent system competing and basically winning over the non-native species that are in there? And then effects on allelopathic chemicals, and we'll hit that really briefly with spotted knapweed, but there are some studies that are just going on, nothing's published, but it's looking at the amount of heat output with spotted knapweed, for instance, which produces allelopathic chemicals, and indicating that likely a fire of a certain intensity and severity will actually volatilize those allelopathic chemicals. So it's kind of another use of fire, separate from kind of that direct effect on the a certain growth stage. It's actually affecting the seed potentially, and then the chemicals. So the dilemma right here, I think far side pretty much highlights it. If you add invasive species in your restoration or maintenance areas, well, you might create the perfect storm if that species loves fire. So it's more, what do you have to do? Do you have to get rid of it first, or can you use fire maybe to affect it negatively? And then is there potential to have colonization? So you might say, man, we did a good job here getting rid of most of the invasive species knocked down to a low percentage, now we can burn. Well, if your neighbor's property is loaded with them, they might easily jump the fence, so to speak, and be happening there. So thinking about decrease in flammability, just in general terms. So again, if you look at, and I'll get this up, what is the density and or distribution of those non-native species? If you don't have any, great, then you need to really work to keep those out. But once you start getting it in, it really gets down to the density and percentage. And this is thinking about invasive species that do not really contribute, they don't burn well, they don't contribute to the fuel load. They actually reduce that fuel load and break it up. So it breaks up that fire spread, or the continuity for fire spread. So basically, there's less fuel available for fire, therefore you can't really achieve that heat output needed, both for your native species and your non-native, to do anything good. So, if it slides to, this picture here on the right side, you're going to have to you might use fire kind of as a stopgap throughout there, but you're probably hitting them heavily with other tools to knock those invasives back down. So where's that tipping point though? That's what you need to determine on any one site, is where's that tipping point where that percentage of invasive species density or distribution actually changes your prescription parameters based off a fuel model. You can't really use a fuel model anymore as well, because it's adding another component that fuel models aren't necessarily designed for. So the change in flammability also is going to change from dormant through growing season. And that's obviously has to do mostly with that increase and decrease in live fuel moisture. So backing up again, think about overall goal. Think about, this is a target. The target's your overall goal. And you're pitching arrows at it, shooting arrows at it. Each arrow is an objective, and you're trying to get those objectives clustered. So really, it's the repeated burning. So if you're going to do a burn and say, man, with this one burn, we're going to wipe out the invasives, good luck, I hope so. But chances are it's repeated burns, it's repeated efforts. So it's having a long-term goal and recognizing, what are your primary objectives? Each treatment you're doing, can you string those together to actually get to good conditions? It's also make sure that every land manager recognizes that no matter what you do, anything you do is going to have a positive or negative impact, including no management. So there have been burns that I've done where we recognized we were going to increase that non-native species, but we needed to get the burn in there at that time for another objective, so we planned to treat that invasive species with another tool, kind of as a stopgap, before we could maybe come back and focus on it. So it's recognizing that there's always competing objectives, and how do you balance that out? I'm throwing this up. I'm a wildlife biologist and conservation biologist by training, so I can say from the ecologist viewpoint, and we're all biologists and ecologists, certainly, but if you take that too far, everybody's seeing this here. Management recommendations are okay to burn when you minimize impact. So, when turtles and snakes are hibernating, when insects are dormant, on and on, okay? But don't burn when any of those critters are moving, right? I like to be blunt and say, well, if you have individual species that are living in a fire-dependent system, if you and I go stand in front of a fire, what's going to happen? We're probably going to get hurt or die, right? So will they. They need what the habitat produces. So and again, I work with teeny species almost exclusively, so it was always that balancing act of how do we not negatively impact too many individuals and take that viable population and trash it. So it was always a lot of unknown. So if we do this single species or continue with the single species approach, or worrying too much, thinking about larger scale activities, we're restricted to our traditional seasons, okay, the spring and fall. And I don't like saying traditional season because I don't think it's traditional, but that kind of puts us into a tight box. And we lose this big opportunity here. Oop, what did I just do? There. We lose the big opportunity of May, June, July, August, and again, this is thinking from the Midwest area. And obviously for I like to call them the extreme biologists that are interested in one individual rare species, when they say, well, burn in December. Anybody look outside today? I mean, it's what, February right now? Is it actually February today? Yes. Can you burn? Man, if you can burn out there, I want to be in your group. So, you know, that's the other thing, is we're not actually achieving good effects. So I always like to throw this out to bring it back to thinking about fire effects, the ecosystem response. And again, you know, Mike, we had talked earlier, but again, it's thinking about fire intensity and or severity, and what do you need to achieve those fire effects? And then you can backtrack it to the fire behavior and weather that you need, and those, that becomes your objective. So your fire effects better link up with your objectives, otherwise why are you doing burning? And I pointed out in the other talk, you know, I've heard people talk about, you know, I need a high intensity burn, and the question is, well, do you? Does that achieve your fire effects or not? Or are you looking more at severity? You know, so it's really balancing out what do you really need to achieve those fire effects. So again, fire energy affects ecosystems and the individual species. That's the big picture. Jack pine burn. Who would like to, that look fun? I mean, there's the fire monster in there. Okay, that's a wildfire. Totally different intensity, severity, right? And potentially from that, there you can barely see the flames. Okay, which one do you think did the most good? That's a trick question. It depends what your objectives are, right? So, but if you're trying to deal with invasive species, typically it's that longer residence time. It's approaching more of that severity. It's less to do with intensity. It's more that transfer of heat output, reaching into that lethal temperature at the right time, active growing. So I just say, it's, again, think about a candle. You know, if you take your hand and wrap it through the flames, what happens? Nothing. Right? But if you hold your hand even far above, pretty soon it gets pretty hot. So just keep kind of thinking about the residence time. If you're not if you're not a fire person that's controlled it, work with your fire people so you're not putting them in a box so that they have flexibility to be thinking. I've seen plans where people are saying, well, we need a rate of spread of this with a backfire. It's like, well, do you? You're really tightening your window by kind of putting those restrictions in. Maybe you need to have a range of rate of spread and a range of intensity you want to achieve, and that'll kind of open up your prescription. And don't forget seasonality. That's what it said on the last slide. So again, this is where I was giving, in the last talk was impediments to growing season burns. I hate to say silver bullet because it wasn't necessarily, but the more successful use of fire I've had with impacting invasives was always in the growing season, always. So when we did dormant season burning, it was more the recognition of what other treatments are we going to have to follow up with, or are we setting it up to treat those invasives later on. So my experience, again, jack pine forest, barrens, oak forest, oak barrens, savanna, sand prairie, however you want to term those. Music prairie, prairie fen, sedge meadow, so we get into wetlands also, so a good combination of uplands and wetlands. Point this out again, thinking about phenology. So if we're looking at whether it's a grass, herb, especially getting into woody species, it's that leaf out and flowering that are the most susceptible. Okay, and that applies to whether it's invasive or native. You don't want to negatively impact the native species too by potentially being at the wrong time. It's also a recognition that as you move kind of through the season from spring, summer, fall, generally you have a change in soil moisture. As you move into growing season, later growing season, you have less soil moisture, lower insulating ability, potentially higher severity. Okay, you have live fuel moisture mixed in. That helps though with residence time. So if you're trying to get that heat output per unit area longer, burning and growing season just by that live fuel moisture helps you there. That lower insulating ability allows that transfer of heat down better. Put this up, the general rule of thumb in the Midwest is when you get to in the 20s RH, it's potentially really hazardous. Okay, high risk burns, right? And I gather it's pretty similar here, potentially. With invasives, if you get into certain densities, you can drop that RH lower. You gotta fight that internal battle potentially with the agency you're with, if they have a hard and fast, nothing below a 20% RH. But we burned at really low RHs with high densities of invasives, and we could barely get the invasives to burn. These are ones that are not providing fuel. What that did though is delineated those dense patches where we could hit with other treatments. And for the outliers, the isolated individual non-natives, we were able to actually knock those back. So it's just kind of, again, using RH as one example. We know there's a lot more parameters that go into it. So there's an example, a variety of different species, and I could add more. Pennsylvania sedge is a competitive species in the Midwest. The rest are non-native. But you can see if you focus more on that dormant season, whether it's in the spring or more later into the fall, you basically, I'd like to say, tick them off. You make it perfect for them to actually take up the mineral release from that disturbance. Versus when we moved into that growing season windows, and there's differences between May, June, July, and August, that's when we were able to negatively impact. And the reason they're red and green arrows, I like to think of green as that's what we wanted to do, and the arrows down, it means we're knocking that invasive percentage lower. And that timer went out, by the way. I can't speak. Okay, so quickly some examples. Okay, that's perfect. So we got a couple examples we're working through. So thinking about oak barrens, and if they're suppressed, you know, we have our stresses, which might be a variety of non-natives, but the source of stress is potentially fire suppression, fragmentation. Okay, not potentially fire suppression. It is fire suppression for these systems. But let's focus on knapweed for an example. It can be controlled with fire. You'll find in the literature that people say, oh, no, if you burn, you're going to increase it. Most of the studies are based off one burn where there's already a density of knapweed, so there's a lot of seed there, which, hey, I can tell you, if you burn where there's a density of knapweed, you're going to increase it. But if you move into that spring, summer, when we moved into late spring or summer burns, repeated burns, that's when we were actually able to reduce it. And that was with fire alone, and then when we added tools onto it, actually we could accelerate kind of the pace of the restoration. But it had limits. For us, it seemed to be when we got to about 20 rosettes per square meter, and that's again across a lot of sites, the knapweed just doesn't burn well. It's got silica somewhat, silica content. It did not provide fuel, and that we kind of lost our heat output at that point. So then we would, if we had that dense, we'd have to approach it with chemical or other treatments until we could actually get some native species in there until we had fuel. So just an example, I mean, it doesn't look like much of a fire growing season, and that's still pretty dense knapweed in there. But again, it doesn't look impressive, but it does the job. And that was done with a black, there was a black line put in weeks before, and then the burn, just to show, so it was very low impact. Pointing this out, here's a study with Ian McDonald that I assisted with here, that what he was looking at, and these are gravel pits, that if you could increase the native grasses, mainly big blue stem Indian grass, they were very competitive. They love fire, obviously, and they basically filled up the space and outcompeted the knapweed. That's a great thing to move from non-natives, and again, you can see the knapweed wasn't that dense yet. I'd rather deal with a few native grasses and figure out how to punch holes and get forbs and everything else and increase diversity that way, than to deal with the knapweed at the same time. Consider alternative methods. So if you're on my fire crew, would you like doing this? Okay, I see a lot of people going, yes, that's good. Because so we did employ this, called swap burning, where we could not get a fire to carry because it was so dense. We just took propane torches and basically burned the heck out of it. These torches put out a lot more heat than any prescribed burn would. And it was astounding to see you could have. So essentially we were mowing with fire. And you could do that repeatedly, and cost effectiveness, it actually was no different than if we applied chemicals or anything else. We have kind of the data to show cost and effectiveness of different tools. Pennsylvania sedge, just a quick mention of this, there's a growing season burn in it, but for us, Pennsylvania sedge produces a dense mat, it alters the fuel load, and it definitely inhibits other native species from growing there. If you burn in the spring, you're going to get more Pennsylvania sedge. When we burn in the growing season, that's when we could basically break up the mat. And we didn't want to get rid of it. It's a native species, but it had a real competitive edge. And we did a lot of different plots to test, and we kind of could, I don't know if it's hard to see, but you can see the reduction there in that sedge mat was definitely inches, basically got it closer to that mineral soil. Red maple, mentioned this here. So same burn, heading portion, and these were large burns, so this is I think a 400-acre burn. So a good bit was head fire, and then a good bit was backing fire. And the main goal was to knock red maple down. Basically try to top kill it, total kill it. The goal was really total kill, but we know how tough that can be. And looking at this, which one do you think was successful? The backing fire or the head fire? And it is a trick question. The head fire, again, it's like a flash in the pan, burned through, and all those little stems it just knocked down. But there's the result. It just resprouted back. The intensity wasn't enough at the base of those maples, even the small maples. They just all resprouted back. So we top killed it, bought a little time. That back burn here did not look like much when they were really leafed out. But again, it's that long residence time, that heat output. We also did a lot of burning at night when possible if the humidity recovery did not basically make it not able to do that. And some really good effects with that too, because it extended the residence time. And you can imagine the burn crew loved doing the night burns with that. So just real quick with these, again, buckthorn. And the picture on the left, the picture on the right is 10 years later. Same photo point. So when we were approaching this, it was like, are you kidding? It's not a fire retardant system. What are we going to do with this? So again, it was really looking at how do we get rid of glossy buckthorn. Obviously, there's no fuel right there to do anything with. So a lot of labor-intensive removal of the adults. When you get that done, you get an amazing explosion of seeds, about 2 million seeds on average, or seedlings, excuse me, about 2 million seedlings per square meter on average. And a volunteer actually counted them all. I mean, he broke it up and had a 6 back and counted them, but so I don't know how accurate that is. But anyway, so the problem is this, is if you don't do anything with it, it can be a real issue, and we didn't want to use herbicide. So we did spot burning. We used propane torches. And the surprise with that was we got a lot of native response coming back from that extra heat output. Basically, we're burning off a micron of that soil and exposing seeds in that prairie fen. And there were species, state threatened and some endangered species that had been seen for quite a while that were popping up by reducing just a little bit. So it's like, oh, okay, well, we learned something big. So the spot burning is fun. It's very labor intensive. But once we got to the point where we had enough fuel, then we moved into, and this was a dormant season burn. We were doing it mainly because we wanted to get those native species reproducing seeds, and then finally start breaking up the season of burning. So there's an example where we just did, just by fire alone, we were able to do the timing and take the buckthorn out because it wasn't that dense to begin with. And then garlic mustard, mainly we used fire to delineate the patches and then went back in with herbicide or propane torches to take out those patches. And Phragmites is a perfect example of the other extreme, where if you get Phragmites in there, it's a totally different fuel model. So there, it's a combination of burning and herbicide that's going to take that out. And the Michigan DNR is pretty well dialed in. I ended up looking at a lot of their prescriptions when we were doing it. And it's pretty dialed into what you need to do in order to burn it. And again, you're using fire mainly to remove the biomass, so you can then do something with herbicide. But it's a very hazardous fuel if you've never seen Phragmite burn. Questions? And there's not a Kelvin or Hobbs, you always got to have them, right? So no trick questions.
I had a question about the prairie burn, the prairie fen. What was your soil? Did you have an organic layer in there? And when you're spot burning, is that a problem because you may ignite the...
Yeah, that's a great question. Yeah, so we did a lot in different prairie fens and knew the depth. Some of them were 20 foot or more depth for organic material, others were a couple feet. That was always part of the briefing and training for the crew doing it, is to make sure that they were not burning around roots that could carry down in, that we were really following up, making sure that if we had any of the sedge hummock start, we did not let them actually start getting down into that organic material. And occasionally we would, but it was making sure we did not. With the prescribed burns, there's only one that I know of that I can remember where it actually started digging down in. But we also had a variety of homemade mop-up ones, and there's seeps all over, so we were able to basically just saturate underneath and help put some of that out. But yeah, that's a definite concern. Keep an eye for that. Did I get that question? Okay.
Jack, I love your comment about not having trouble getting some of your pieces to burn, even on what would be considered a serious burn by some people. We had a similar experience in Florida where we ended up burning in a plantation on a burn day. It was like had rained a bit, and the RH was like a low heat, and it was like going everywhere. And it had been mowed even beforehand, so there's lots of fine fuel on the ground, but it did not want to burn. I mean, and what was interesting is it was in this little bowl, and so you could hear the wind howling above, and there's no air movement. Like in our little unit, we were surrounded by wetland forest. But so it was kind of eye-opening to me, because like that morning I was kind of thinking, wow, they're going to have like a cool fire here. That's going to be neat to see all these young get killed. And then in fact, it really didn't. It didn't do that. I went back 2 months later, and the guns were taller than they were the day we burned. And so it's just anyway.
No, it's a good point.
There's so much moisture, I think sometimes in these fuels too that are not native, or just maybe not what we typically want to burn. There's so much moisture that it just quenches, and it's also low-grade fuel.
Right.
Like so if you don't really burn gum that much in your fireplace, it doesn't output that much heat. And so that combination, I think, really, you got to consider that when you're burning.
Look at potential burn days, I mean, based on the fuels or lack of fuels they have.
Jack, I had one more question related to Pennsylvania sedge. Did you look at dormant season mowing and increases related to species like Pennsylvania sedge, as well as the dormant season?
We compared chemical treatment and fire through different seasons. We didn't do any mowing, just because it wasn't easy to get into these sites necessarily with a mower and do it. So my comparison is between chemical and fire, and then a combination of those two. But we're also thinking about it, it's great if the chemical and fire maybe works more effectively, but when you try to scale that up to large sites, it's hard to do chemical over larger areas. So we were looking to see, how can we use fire, and is it effective at a certain time or not? Or we're gonna have to come up with another strategy. So, for large landscape burns, and if you have a Pennsylvania sedge problem, burning in the growing season will start to knock the teeth out. And that doesn't mean you keep doing growing season burns. Then, it depends on the system and what your objectives are for each repeated burn. But yeah, you're not going to do huge chemical treatments over large areas of that. It's just that the price goes way up and the labor.